Welcome to today's video presentation. I am Carlos Nicolai L. Benito, and today we're going to dive into the principles of inheritance using our enrollment system. In object-oriented programming, inheritance allows us to create efficient and adaptable code structures. Imagine a blueprint for a house. Inheritance lets us to leverage that blueprint to create different rooms, which is the classes, that share common features but also have a specialized functionalities. For our agenda, we have to understand inheritance in the system, in our code, strengths of inheritance, and example code, and our conclusion. Understanding inheritance. Base class. Think of it as the house blueprint. This class defines common properties and methods that will be shared by other classes. As you can see in our code, here is our class register, which is our base class. For derived class, this is a room built upon the blueprint. It inherits all the properties and methods from the base class but can also add its own functionalities. For our derived class, it is the class payment, which is the base class is the register. Inheritance in the system. Now let's see how inheritance works in our enrollment system. We have a register class acting as the base class. This contains methods for capturing student information like name, year, level, program, and potentially student ID generation. The payment class is the derived class. It inherits all the functionalities of register like capturing student information. However, payment can then add its own specialized methods for calculating fees and assessments based on course type. For the strengths, this reduces redundancy. You only enter your information once during registration. Since payment inherits from register, your details are automatically carried over, saving your time. Second, streamlined process. The payment class builds upon register to handle fees and assessments seamlessly. Inheritance avoids unnecessary steps, making the registration process smoother. Third, flexibility for courses. Whether you take regular courses or choose irregular ones, the system can adapt. Inheritance allows the payment class to handle different assessment methods of each course type. Example code. In the code, you might see something like class payment public register. This syntax signifies that payment inherits publicly from the registered class. Within register, there are likely methods for storing student information, like this below. The payment class then leverages these methods and expands upon them with functionalities specific to fee calculation and assessments based on course type. For our conclusion, by leveraging inheritance, our enrollment system achieves efficiency and flexibility. It reduces redundancy for us, streamlines the process, and adapts to different course types. As the system evolves, inheritance paves the way for future functionalities to seamlessly integrate and build upon the existing foundation. That's all. Thank you.
So, the other principles of OOP, the encapsulation and abstraction. First, I will explain how we implement encapsulation on our program. As we can see here, in this private access specifier, we declared variables, which is the last name, first name, middle name, and the other variables. And we don't declare functions or methods in this private access specifier, but rather only on the public access specifier. And after those variables, we also created a getter for private variables, because that's how we really access private variables through their getters. Uh, for the other class, the payment, which is inherit the public register, we also declare private access specifier here and initiates variables and no methods. We don't really created a getters for the class payments because that's the first initiator of object on the main function. After those classes, which really holds a complex logic about manipulation of data coming from the users. Uh, After that, the main function, which is the initiation of their objects. For the register, we created a student thread for its objects, for its object, and the payment, which also have an object named student processing. As we can see here, the student thread, which is the register, access the file insert, which from the uh, concept of polymorphism, we have the multiple file insert functions, but different classes. The student file, the student processing, we can see here, it access the getter of the student register class so that the content of this getter will be sent through the parameters. In the main function, this is where it comes the abstraction. For our abstraction, we can see it's really bunch of functions and classes names, because the principle of abstraction is really just holds complex data from the user perspectives. Those function declaring, and some prompt for the success and the list of students, and that's it. That's how we implement encapsulation and abstraction in our program.
And good afternoon, everyone. I am Jude Perez from the Group 3 in our MA3 in Integrative program. And today I am going to explain how polymorphism is implemented here in our program. So to start off, first, polymorphism enables that for an object of a different class to be demanded or treated as that of another higher class. This is realized through a technique known as method overriding or method overloading. So the potential polymorphic usage, it is possible to override some of the methods such as file insert or assessment in descendant classes due to the fact that authoritative classes register and payment may contain fields and properties depending on various types of students or particular payments. So here we have in students, the file insert here should be around here. Yes, we got it here. So it's getting inserted the file names, full names, section, guardian. Most of the students and basic information is held on this particular function, especially here in register. See how register and class register is being reused in this function. So yeah, you see the what type of scholarship the student is taking, the basic information, year level, etc., etc. So another file insert is found here, another function of in register, which is this is where the student is getting stored the information of the student is getting stored. And here we have in payments, yeah, it's and it really calls out register because this one applies the student's scholarship, it perhaps, and the additional miscellaneous fees, computing all of that. Another file insert is found. Another file insert function is found here. Notice how it has the same name, but it has a different parameter. So mostly it is implementing a override, a type of polymorphism. Another payment is found here on assessments. I think, if I recall correctly, there are two assessment functions that is called out. And see how in this particular section it is shown to have the function to enter the units and courses for irregular students. So you see, and it also prompts the payment regarding miscellaneous and other fees. And that's pretty much it for the functions of polymorphism and how it is implemented here in our code.